Well, hello and welcome. This is Joe from I Repair Electronics, and going into sewing machines today. So, there's a lot of videos that cover this issue of where when you press on the foot control for the sewing machine, it goes off too fast, or there just isn't enough control. And usually, what they do is have you adjust a little potentiometer inside the foot control, and that will usually take care of it. However, in some machines, like the one I had, of course, that didn't do the trick. And what was happening is the second you hit the foot control, the second you engage it, it just goes on full bore as fast as the machine can go. So that's why I've created this video. And we're going to go over the problem and the solution on how to fix it. And I'm also going to present to you a reverse engineered schematic of the foot control wiring diagram. So stick around, watch, and learn. Well, hello viewers, this is Joe from I Repair Electronics, and I'm going to make this a quick one. This is a little variable speed pedal for a Singer sewing machine. So the problem with this is that when you press on it, it just goes from 0 to full speed, and there's nothing in between. So with that, let's take a look into this thing. On the bottom, you'll see there's a pivot point right here and here. They're just cheap little plastic thingies. They pop right out, like so. Pull it out, prepare for a spring to spring, just like that. It sits inside of here and rests against the little post on this slider. Let's move that out of here anyway. Okay, so what I did when I was attached to the sewing machine upstairs is I tried adjusting this little potentiometer. This little variable control here was set over to this position. And I tried it here, tried it there. Nothing did anything at all. Go full bore, full speed ahead. So let's tear into it. Let's just pop this off. This is a little springing thing. Let's get that here. You take this out. Just remember that it goes this way down. And unscrew this. As we might suspect, is probably this transistor. It's just, I don't even know what it is in terms of its make and manufacturer, part number, I don't know. Let's just try it out, see what that is. .360 from there to there, nothing here. Let's try reversing the leads. And we get 0.362, so if I had to guess, this is probably an SCR perhaps, or a MOSFET. This, you see this little diagram? That should be a Diac, I think, if memory serves me right. And we're not gonna read anything in diode mode either direction. If you look at the symbol, it's blocking current in both directions. So, well, okay. We'll look at that later. Maybe we figure out another test for that. Let's look at the resistors. And try and keep my hands out of the way. So we got what? Brown, black, red, 1K, says 0.980. It's within tolerance. We'll let that slide. We got orange, 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 33K, 32K. Well, okay. We can let that go. What we got here? Another 1K, or yeah. And no. 0.673K, and that's orange, black, red. That's a 1K. That will not do. Definitely not. So let's take a look. Get the solder wick on here. Solder this bad boy. Let's pop a lead so we can get a true measurement on this. Because you never know, I might have been reading something in circuit. Alright, let's get this back in here. And one into this, one into this. 0.67, whatever. No, that's not good. Let's get this out of here. And here's a new 1K. Let's verify it. .997, that's good. So let's go ahead and install this resistor. And this looks to be like a 1 watt perhaps. I think this is half a watt. Whatever, it'll be fine. It'll work just fine. Can't imagine the current got to it. So let's get this screwing back in. And lever action in here. Just springing over here. Oh, of course, everything is just pop out on you, doesn't it? Let's try again. Like that. Let's keep this about here. Keep this around there. There we go. And let's see if we can't get this back together in one piece. Let's try it like that. Make sure that the spring meets the little stud there. Put this end in first. Put it back together. Sounds good. Let's try it. Okay, so here we are back at the machine, and let's just see what happens after we've put this together. See if I have any control over the machine. Nope, that's awfully touchy. No control at all. So it was over here. And we'll try and... Oh, banging right off there, isn't it? Let's try it like that. One extreme to the other. Nope. Just firing on all cylinders, aren't we? All the way over here. Okay. Something else, a little more troubling going on in this circuit, isn't it? Yep. When I left off with this control, we were frustrated over the fact that, you know, when you just touch it and get it to move, there was no slow motion on the sewing machine at all. Just slow, or not even slow, just off and running full bore, all pistons. And it's not how it's supposed to work. So I've studied the circuit pretty good, and there's not a lot to it. There's an item called a Diac and an item called a Triac. Now, one of these is bad, and I suspect it's the Diac, which is just the little blue item right next to the large transistor-looking item, which is the Triac. Now, I'm going to show you a schematic that I reverse engineered myself. So if you're adept at reading schematics, you can take a look and discover how this works. If not, then just skip forward a few minutes. So here's the schematic that I reverse engineered from the circuit board. The input on number 2 is the voltage coming in, and where it says number 1, ST1, with the arrow pointing out, or pointing down rather, that's where the output voltage is. And it just varies the amount of voltage going to the motor. So apparently this is a newish design on an older setup, where some of the older ones had a variable resistor that was just a big stack of carbon plates strapped together, or they used a transformer of sorts and used a variable resistor in that as well to adjust the output voltage going to the motor. Either case, those old designs were a bit clunky, a bit not on the safest side of things. So this is pretty much why Singer and a whole bunch of other companies came up using this particular approach and this circuit design. That's the Diac, and that's the Triac. Problem was with this Diac thing. There's no simple way of testing a Diac with a multimeter. I just had to go on my gut instincts that, well, it was pretty simple. None of the other components were all that bad. There are ways of testing the Triac, not 100% guaranteed, but there are ways of doing that with a voltometer. And it seemed okay to me, so I went with the Diac. So I'm gonna hit it, and as you see, it draws the solder up into the wick, hence the term solder wick. And you heat it up again on the other point, and sucks it on up. And then you could just use the tip of your soldering iron to kind of loosen the tabs and get the component out. And just like that, There it is. Well, I bought a few of them. You can buy just one. Or when you buy a few, you get them like this. Let's snip one out. And the one nice thing about the Diac as a component is that it does not have a polarity, so you don't need to worry about which way it goes in. Things like diodes and electrolytic capacitors do have a polarity, and it's very important with those type of components, but this one goes the same in both directions. I can maybe show you a diagram in a bit, what that looks like electronically, but if you're not interested or you really don't care, it's not all that important. All you need to do is just change this out. Here's on the other side. We're going to get some solder. And just heat it up a little bit to get a nice little teardrop looking look to the joint. Same over here. Let it heat up a little bit, pull it up, and until it looks like that, a nice little flowing teardrop kind of thing. And of course you snip off. You should have a pair of side cutters or some sort of something similar. These of course are meant for getting into very tight spaces. You don't really need something as crazy as that. Okay then, so we've replaced the component, which was the Diac here, right? And I'm going to start off showing you how this little trimmer works. It was at this position, which I call the 9 o'clock position, because if you look at it in this direction, it's at, well, actually it's at 3 o'clock. Sorry. Yeah, so that's the 3 o'clock position. So we lay it like this just for simplicity's sake. Now, here's how the machine operates now. So there's a nice amount of, a little very slow motion, that grunt right here. You get that grunting sound, right? And it's moving ever so slowly. Now, as soon as you come out of that, it starts to move a little more faster, but it's got a nice gradual increase. Now, if you want, what you can do is, if you're like me, you have a heavy foot on your pedal, you can adjust it with the potentiometer. And so what I'm going to do is I'm going to turn it, and don't handle it quite like I do. You should at least have the screw down. I'm not scared of electricity, but for yourselves, I would suggest screwing it down so you're not dealing with a board flopping around on you. But anyway, let's go. And we're going to bring it up to a grunt, right? And it's just barely moving. I'm going to turn this back, and now it's not moving at all. All right? Move it up again. It's just barely moving. Just barely moving there. And see if we can bring this back even more. And I can. Right about there. So we still have control over this, but a little more range. Now it's moving slowly, and then you have the rest of it. So you still have the rest of it to go. If you really want to go insane and be a speed demon with the thing, you can. But it's giving you that little more bit of control with the control turned almost at 9 o'clock. It's that little center detent where the wires sort of touch the control. that is at about 10 o'clock. So that's it for fine-tuning your control in there. Like I said, do make sure you put the screw back in. I was sort of in a rush to show you. So anyway, that's the roundup of how to adjust the control. But wait, don't go anywhere yet. I'm going to show you the reverse engineered schematic next.